Consuelo, everybody. Okay. For some of this, I'm not really sure how important it is. But, it's like on the last file, or the last video, I said, what's an inverse function? It kind of bothers me just to leave you hanging there. Okay, and I'm still not going to really get into this until chapter 7, but what's an inverse function? An inverse function is something that undoes whatever the original function does. Okay, so for example, f of x equals 2x plus 7, and f to the negative 1 of x equals x minus 7 all over 2. Okay, they're inverse functions of each other. Okay, notice if you plug in anything into the original function, okay, it says multiply it by 2 and add 7, so you get 2x plus 7. Let's say you take that 2x plus 7 and you plug it into the inverse function. You would subtract 7 and divide by 2, and what do you get? X. In other words, it undoes whatever the original function does. Okay? Now, again, I don't know how important it is for you to know this, because you don't need to really know this in order to find an inverse function. Okay? You just do what we did in the last, the last video. But I don't know. I just kind of like to mention this. Okay, now, why am I mentioning this at this point? Okay, how do you prove, if you want to prove that two functions are inverses? Okay, what do? Well, one function should undo the other function. That's what an inverse function does. And if one function does not undo the other function, then they're not inverses. Okay, so let's take a look. Let's take a look at problem number 1. So let's find the f of g of x. So the g of x is 1/3 x minus 4. Now, notice what we're starting with here is x. So if these things are inverses, we should end up with x. When we're all done, we should end up with x. So g of x is 1/3 x minus 4. Now let's find the f of that. So we take 1/3 x minus 4, plug it into the f function, calculate it, and what do we get? The same thing we started off with. Okay, let's see if it works the other way. Because it should work both for f of g of x and g of f of x. So let's find the f of x first. So in part B, find the f of x first. Then we'll find the g of 3x plus 12. And notice, it also gives us back what we started with. Since one function always undid the other function, they're inverses. Now let's take a look at something they're not inverses. Okay, so we've got the f of g of x is 1/2 x minus 20, so the g of x is 1/2 x minus 20. The f of that is x minus 30. Notice it did not give us back what we started with. Okay, for the g of f of x, find the f of x first, then find 1/2 times 2x, the quantity 2x plus 10 minus 20, and what does it give us back? Notice it doesn't give us back what we started with. That's why they are not inverses. Okay? Now, that's just kind of something real quick. That's how you prove. You find the f of g of x and the g of f of x, and if they both give you back the value of x, they're inverses. Okay, fine. I just mentioned that again. What I want to do is just go through some more problems before I actually start giving you problems to do on your own. Okay, so given the g of x equals x plus 9 over 11 and h of x equals what the function you've got there, I want you to find the following. Problem A, B, C, D, E, and F. Okay, well, in order to do this, you need to know 4 functions. You need to know g of x, which I gave you, h of x, which I gave you, but you also must know g to the negative 1 of x, which you have to figure out, and h to the negative 1 of x, which you have to figure out. So before we do any of these problems, before we can consider doing any of them, we first have to find g to the negative 1 of x and h to the negative 1 of x. So let's do that. Okay, so for g of x equals x plus 9 all over 11. We switch x and y, solve it for y, and we get this. So right now we know what? We know the g of x equation. We know the g to the negative 1 of x equation. We know h of x. So the only thing left for us to find is h to the negative 1 of x. So we switch the x's and y's and get that. Okay, now let's answer the questions. And notice there are 4 functions. There's g of x, g to the negative 1 of x, which is different than g of x. There's h of x, and h to the negative 1 of x, which is different than h of x. All right. So make sure you're using the proper function. So letter A, problem A, says find g to the negative 1 of 4. So which one do we use? We use this one, because that's the g to the negative 1. So we take that equation, plug in 4 for x, and then calculate it. Okay, part B, find g of 4. Which one do we use here? We use this one. Why? Because g of x is different than g of negative 1 of x. You have to use the one that's got the name given in the problem. And the name here is g. The name in the first one was g to the negative 1. So we use g of x, we plug in 4, and calculate it. Okay, for h to the negative 1 of 0, which one do we use? We use this one right here, because that's the h to the negative 1. So there's a point 0, negative 7, so the y-coordinate's negative 7. Remember, all it's asking you is what's the value of y when x is 0. For letter D, h of 0, which one are we going to use? We're going to use this function right here, because that's the h equation. So we find the point that's got an x-coordinate 0, and your y-coordinate's 5, so that's the answer. Okay? All right, now let's find the g of the g to the negative 1 of 1. So what do we do first? We have to use the one in the parentheses first. This is the one in parentheses right here. So using that equation, we find the g to the negative 1 of 1, which is 2. Okay, fine. Now what do? We have to find the g of 2. And which equation do we use for that? We use this one right here, because that's the one that says g. So you plug in 2, and then you calculate it. Okay, for the h of negative 1, okay? First of all, we do what's in the parentheses first. And notice I'm rewriting this one. So I'm using the other notation. Why? Because you're going to have to get used to it. So basically what we're doing is this. So we're using the h to the negative 1 first, so we're using this one first. And there's a point that's got a y-coordinate of 7, and its an x-coordinate of 7, and its y-coordinate is 3. Then we're going to use this equation. Why? Because at this point, we now have the h of 3. So there's a point that has a x-coordinate of 3, and its y-coordinate is 7. Okay? You just have to be very careful about notation. Problems are not that hard, but notation can really mess you up. Okay, that's it. So next one, I'm going to have some for you to do, and you do them on your own, and then check with the answer. Have a good day, everybody.